Okay, so let's get into our first problem. What I want to do when I'm going through these problems, what I want you to do is to think about what the problem is actually saying. I don't really care if you're not really paying attention to the numbers the first time you're actually going through these problems, but think about the situation, and I'll help you out with going about visualizing that. The first problem says, light from the sun reaches the earth in 8.3 minutes, which is equal to 498 seconds. The average velocity of light is 3.00 times 10 to the 8th power meters per second. How far from the earth is the sun? Now, once again, I just want you to read the question itself again, but let's not even include the numbers. Let's just read the words. So light from the sun reaches the earth in this amount of time. The average velocity of the light is this. How far from the earth is the sun? Okay, so let's think about what's happening here. So I'm just going to draw a little visual here. Say if we have the sun over here and we have the earth over here, what we're basically saying is, hey, you know what? Sunlight is going to travel from the sun and reach the earth, right? That's the situation. We know that it's starting off over here. That's the initial position. And the final position is going to be over here. So what I like to do is this. I like to pretend, say if we are standing right on the sun, which is, hopefully you know, is physically impossible, but would be awesome. Okay, so if we're standing right here on the sun, and we're watching the light go all the way over here to the earth, let me ask you this. What do you think the value is that we're going to be saying is the initial position of the sunlight? If it's right here, then it's going to go all the way over to here. Initially, it's going to have a value of 0 meters. That's the initial position. So let's go through here and pull out the given information that we have. It's going to take 498 seconds, which is equal to 8.3 minutes. Hey, which one of these units do we want to be using? Once again, if we're referring to this over here, we know that time is going to be measured in seconds, so let's actually just use the 498 seconds. So we have our delta t, which is 498 seconds. The average velocity, ooh, look at that. All right, so we are being told that the average velocity over here is 3.00 times 10 to the 8th meters per second. So we also know that's velocity, being that we're given the units, and we're being told specifically that's the average velocity. So we know that our variable that we're going to be dealing with is v. So 3 times 10 to the 8th power meters per second. All right. And how far from the earth is the sun? Okay. So wait a minute. If we actually know that the initial position is right over here and that the final position is over here, isn't that really just how far away it is that's describing the final position? Yeah, right? So that's actually what we're going to be looking for. Which one of these kinematic equations do we want to be working with? Which one will be best suited for our needs? Well, we know that this velocity here is our average velocity. So these formulas over here, these first two, have to do with average velocity. This line separates the formulas that have to do with average velocity and all of the other ones. None of these formulas over here have to do with average velocity. Whenever we're dealing with average velocity, we're going to be looking at these first two formulas. So I just want to make that clear. Okay, well, looking at the other variables that we have here, are we given our final position, initial position, and our delta t? Well, yeah. Okay, so that's nice. Well, what about this? Are we given our initial velocity, final velocity? No. Okay, well, that's simple enough. Let's actually just use this formula right here. So I'm just going to write that out right now. So we have v is equal to xf minus xi divided by delta t. So we just simply plug in our variables right now. So we have xf, which is the variable that we're trying to solve. Oh, I did not do a good job already. So we have 3 times 10 to the 8th. What I'm just going to do is exclude our units. Your teacher might say, hey, you know what? I don't want you to exclude the units when you're plugging in for the equation. But for myself, I don't mind if you actually do exclude the units. It just makes it a lot simpler, a lot easier to manage going through these problems. So xf minus our initial position of 0, divide that by our delta t, which is 498. And we solve this out for xf, and we should be able to get our answer. I'm just going to delete our picture over here. So this subtraction of 0, does that actually add any sort of value to our problem whatsoever? No, right? So all that we basically have here is xf divided by 498. How do we actually get rid of a division of 498? You multiply 498 on both sides of the equation. When you do that, you should be plugging this into your calculator and getting the final position is 1.49 times 10 to the 11th power. And that should be in units of meters. And that's your final answer.